Think we'll get started. So in yesterday's live learning session, we had talked about dictionaries, and then we went into different ways that you can repeat code via a for loop and a while loop. We're going to pick off today by talking about how you can open, read, and write files. We're going to then briefly talk about object-oriented programming. And then the majority of this session is going to be focused on using the NumPy library. It's very powerful, and we're going to see how we can manipulate data using that library. We're then going to spend the last 10 or 15 minutes going over assignment 2. And then a reminder that tomorrow we actually have our case study. So today wraps up all of the content for the Python module, all of that content delivery. And then tomorrow we'll have a guest speaker, Tristan from Munich Re, coming in to give us a chat about what he does in his day-to-day work with Python and data science. All right, so let's get started. I said we're going to be kicking off with talking about how we can open, read, and write files. So I'm just going to paste in some markdown code. And we're going to talk about a built-in function called open. The open function is meant for opening files, and it's going to take in a file path, right, or the location of where your file is located, and then a one-character string. So this one-character string is going to tell Python whether we are going to enter the read mode, the write mode, or the append mode. And if we enter into the read mode, it's going to be read only, and it's going to give you an error if that file doesn't already exist. If you go into the write mode, okay, and it's going to write, and if the file doesn't exist, it's going to create a new one. If the file already exists, it's going to overwrite it. Okay? And then the last mode we have is the append mode. So it's going to append, and it works by adding to an existing file. And if the file doesn't exist, it's going to create one. So let's go through an example to help understand this. So if you've downloaded the GitHub repository onto your local computer, there are some data files that I'm going to be referencing today. So you can click on your VS Code. There's this little Explorer button in the top left corner where my cursor is circling. So it says Explorer, and I'm just clicking it. And then I'm going to click Open Folder. Okay. So I'm just clicking Open Folder where my cursor is circling now. It's going to allow me to select the folder of interest. So I'm just going to click that Python directory I have, right? So I have this Python directory with all of the that I copied onto my local computer, okay, with all of the content from the GitHub repo. Oh, I always forget that it will do that. I may need a moment just to open up my files again, but so now it's going to open up all of the directories inside of that Python folder, right? So I can actually go down and navigate to this cohort, live code, and I'm going to open up the live coding notebook that I just had open. Okay, so and if you go into this 05 SRE folder, there's going to be data files for assignment 2, which we'll talk about at the end of today's session, and then there's also slide data. And so we're going to be referencing a couple of these folders today. Okay. I'm just going to stop sharing for a moment so that I can reconfigure my screen. Sorry, always forget that once I do that open folder, it's going to close everything. So just give me one moment. Um, all right, should be good. Let me just share again. Okay. So I mentioned that there is a built-in open function, right? That Python has that allows us to open files. It takes in two arguments. The first is going to be the file path. And usually is paired with this with statement. Okay. So this, I'm going to write it out and then I'll actually go through and explain each part of it. So with open, and then I need to have my file path. So let's work with this California Housing Test CSV. So I've located this in my directory. If you couldn't get this Explorer screen working, right? You can also just find the path on your computer. So for example, let me share my whole screen. For example, here I have wherever the data is located on your computer. So I've just opened it up on my own computer. And then you can have the path. You can go ahead and copy that. I think you can do, um, well, the path, oh, here we are. I think it's copy as a path name, right? So then you can copy in the path. I think if you have a Windows computer, it should be just at the top there. So the point is, if you couldn't get this Explorer window working, just go ahead onto your computer and find the path of this California Housing Test CSV. Okay. So I'm going to go in and I'm going to right click here and I'm just going to say copy path. And then, oops. I'll go ahead and copy that path in. So I've just copied that path to that California Housing CSV. So that's my first argument. Okay. My second argument is going to be a single character indicating whether we're in read mode, write mode, or pen mode. So let's go into read mode first. Then I'm going to have as F, and I'll explain what that means. Okay. So let's break this down. Oops. Sorry folks, I think my Zoom just got a little bit weird. Is everyone able to hear me now and see me? Okay.
Yes.
And is my screen sharing? Okay. Where did I end off? Was it when I was talking about the with statement?
The second argument.
Ah, okay. Sorry about that. I don't know what happened. Um, Okay, so we have here, let's go through each of these parts. So we have this with statement here, and this is going, and then I'll go into the second argument in a moment. But the with statement is used along with the open function. And that with statement ensures that your file is going to be properly closed after the block of code finishes its execution. Okay. Then we have that built-in open statement that I was talking about. And there are two arguments that are passed into it. The first, again, is the path, the file path. So we're just providing the path to the CSV file. And then the second is this R. This is a single character indicating the mode that we're going to be in. So for R, it's read mode. For W, it's write mode. And for A, it's append mode. Okay. And then we have this as F. So what it does is it's this open function actually returns a file object. Okay. And think about that as a representation of the opened file. We assign that file object to some sort of a variable. You can call this whatever you want. You could say as um, file, you could say as Kaylee, you could say whatever you wanted, right? You can just have, so in this case, we're going to choose F, and it allows us to then reference that file object, right? That representation of the open file within the body of our code. So just to repeat this all again, we have the with statement that ensures that the file is going to be properly closed after the code finishes its execution. We have this open function that returns a file object, and we assign it to this f value so that we can go ahead and refer to it in our code. You can call it whatever you want. And then the open function takes in two arguments. The first is our file path, and the second is a single character, either R, W, or A, to indicate whether we're entering read mode, write mode, or append mode, respectively. Okay. So when I run this, you get this really interesting output. So this is printing f, right, which we said is the variable that's assigned to the file object, which represents the open file. So this is just showing information about that file object. It has its name, it has the mode here, right? Mode, and then it talks about the encoding. But you don't have to worry too much about the details of this. The purpose of printing F was just to show that this F, now we can refer to it throughout our code body, and it is a representation of that open file. It's a file object. Okay, so let's focus first on the read mode. Oh, sorry, I have a question to widen the screen. Unfortunately, this is going to be as wide as it gets just so that I can see the chat um, and everyone's faces. But I'll make it a little bit bigger. Hopefully that's better. Okay. So let's talk about the read mode first. I'm just copying in some markdown text. Okay. So there are methods that we have to use in order to get the file contents. And there are three methods. There's read, okay, then there's read line, and then there's read lines with an S. So we can use one of these three different options. Yes, Anna, I see your hand up.
Um, yes, can you hear me?
Yep.
Okay, so we do have like a question about like the path of the file because when we copy the path, the slash is in a different direction.
Mm-hmm.
Is there some way we can fix that, or we have to manually change all this slash into into the same direction as yours? Because right now, the slash, I mean, from my end, is all different and opposite
Yeah.
direction.
You can try putting an R in front of it and then let me know if that runs.
All right, thank you. Let me try.
Um, and then, yeah, give that a shot. It's a, and maybe, yes, the R worked. Okay, great. So yeah, what putting the R in front of it does is it makes it a raw string literal is what we say. So this tells Python that we want to interpret the string as is without processing those slashes, right? So if you have a backslash, if you remember way back from um, our topic on the strings, right? The backslash going in this direction, if it's showing the right way on my camera, but that actually tells Python to interpret it as an escape sequence, right? If you have the backslash and the N, it's saying interpret that as a new line character. Like if you had a backslash and a T, it would be saying interpret that as a tab character. So we don't want Python to interpret those as escape sequences. So we use a raw string and we indicate that by having that R before it. So now this makes sure that those slashes are treated literally for what they are, if that makes any sense. Um, yeah, hopefully that was clear. Yeah, so now we go ahead and we um, can apply one of three read methods, right? So we've opened the file and now we can either return the full file contents with, so there's the read line, and read lines. The first one, read, is going to return the entire file contents and it's going to just output it all. The second one, read line, singular, is going to just return the next line in the file. And Python's going to keep track of where we are. So every time you call read line, it's going to then um, return back the next line, and so on and so forth. And then we have read lines with an S. And this is going to return the full file as a list. And each item in that list, each element is going to be one line in the file. So I know that was a lot of information. Let's go through an example and see this in action. Okay, so with open, and I'm going to use the same file, this California housing tests.csv. So you can just copy it. Um, and if it was kind of giving a weird error before, make sure you have that R in front of it. Okay. And then I'm going to have that as my first argument. My second argument is going to be the R character to indicate I'm in read mode. And I'm going to assign this to F. Okay. So we've opened up this file and we can now reference it by using the F variable that we've assigned it to, and we can apply different read methods. Okay, so let's go ahead and do that. I'm going to start by just doing print f dot read. Okay. So here we said read is going to return the full file content. So if I go ahead, I can see everything in that file, right, has been returned. And I'm reading the full file content. We can also do read line. Okay, so this is going to return only the next line in the file. So you can see it started off by returning the first line. So let's go ahead and add to this code and do for loop. So if I did for I in range 5, so this is kind of tying in some of the content we covered yesterday. So we said we created a for loop and we use this range 5. So this is saying we're going to go through an iterable that goes 0, 1, 2, 3, 4. Okay. So it's going to iterate 5 times. This loop's going to go over 5 different times. And each time we want to print the next line in the file. Okay, right? Because this is read line. So it's going to return the next line in the file. So when I run this, you can see that each time the f.readline executes, I'm printing the next line in my file. So I've now printed the first 5 lines. Um, I'm actually just going to copy what we had before so that if you reference this live coding notebook later, you know, we did the first example prior just with read. Now we're doing read line. Now let's go ahead and do read lines with an S. So with open, and I'm just going to copy that path again. Your path is going to be different than mine. Okay. And then as F. Okay. Um, just looking at the chat, make sure that you have 2 parentheses after read, read line, read lines, right? These are methods. So um, remember the syntax of a method, you have to have those around parentheses. Okay. Okay, and then this time let's do print f dot read lines with an S. So this time, it's actually gone ahead and it's returned the full file as a list, right? So we have a list. You can tell because it has the square brackets, and each item in the list is going to correspond to a line in the file. So this is my first line of my file, and it also corresponds to the first item in the list. Okay. Now I'm highlighting the second line in the second item in my list, and it's corresponding to the second line in my file. So again, we've introduced the open built-in function. We showed that the syntax that you use when you're working with that function, right? You have to have with, open, file path, one of the modes, as, and then you would assign this some variable of your choosing. This is a representation now, this variable of the opened file. Now we can apply methods to that file object. In this case, we've assigned it F. And we've introduced for the read mode that there are 3 different methods. Read, which is going to return the full file content, right? Read line, singular, which is going to return a line at a time. And then read lines with an S, which is going to return the entire file as a list where each item in that list corresponds to a line. Are there any questions about this? Okay. Again, the F there actually is representing the opened file. Think about it as a representation of the opened file. We've opened the file using this built-in open function, and now we're assigning that open file to this variable f, which we can go ahead and manipulate further. Okay, let's go into the write mode next. So let's say, and the write mode, right, has two methods that we can use. So let's make a list. I'm going to call it provinces. I'm going to have BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, Newfoundland, New Brunswick, Nova Scotia, and PEI. Okay. So I have this list, right? And I've gone ahead and assigned it to the provinces variable. I'm going to have with open, Okay, and this time I'm going to include the file path where I want to save my file, right? Before we were providing the path to where we wanted the file was located that we wanted to read. Now we provide the file path to where we want to write this file to. So I'm going to keep it in this current folder, and I'm just going to call it um, provinces.txt. If I wanted to move it to my downloads folder, it might look something like this, right? I'd then put it in my downloads and then I'd have the file name. But I'm just going to keep it where I'm currently located, and I'm just going to call it provinces.txt. And I'm going to be in write mode. Okay, so I indicate that I'm in write mode with a single character. You have two arguments for the open function. The first is your file path, and the second is going to be a single character, either R, W, or A, to indicate read, write in append mode. And then we're going to take this opened file, this file object, and assign it to some sort of a dummy variable. This case, I'm going to call it province file. I have to have a colon, and then when I hit enter, it should be indented. Okay, so let's start with this write lines. If I do province underscore file dot write lines, what it's going to do is it's going to write each item in this iterable. So each item in this list is going to be written to a file with no text, separating text. Okay, so each item is going to be written to a file with no text separating it. Okay, and can see when I take a look at my folder, right, there's now this provinces.txt file. And if I open it, I can see that each item in this list has been written to the file with no text in between it. Um, so I just opened up the file on VS Code, but we can also read it using the with open in that open function again. So if I do provinces.txt, okay, and then I had this in read mode, right? So we just wrote the file. Now I'm going to read it. Uh, as province file. Okay. And I'm just doing dot read. If you remember, dot read returns the entire content, the full file content. So it's just now returning, again, the file that we previously wrote. So it's each of the items in this list with no text separating it. You could even do with open, and I'm going to call this one text.txt. Or, okay, and I'm going to say write as f, and I'm going to say f dot write. This time I'm going to use this dot write method, and it's going to write a string to a file. So I'm just going to say it is December 4th. Okay. Again, I can look at my file explorer, this explorer on the left panel, and I can see this text.txt file is being created, and in it there's the string, it is December 4th. I can also read it using the open method again. Okay. And I can see it says it is December 4th. To answer the question in the chat that says, how do we know where is the file we just created? You indicate where it is created here. The first argument to the open function is going to be the file path. So right now I have saved it as a TXT file called provinces in my current directory where I am currently located. So I'm in this live code notebook. I don't know where folks are, but it depends on where you're located, and then you can go ahead and access that. Okay. And if you wanted it to be in a different folder, you would just have that file path. So if I wanted it in my downloads folder, it would look like this, right? And then it would go ahead and save that to my downloads folder. Yeah, a hand up.
Hi, can you hear me?
Yeah.
Yeah, thank you. I think I miss a part of conversation, but I'm a little bit confused. Text.txt is the file name, right?
Yeah.
And we don't supposed to put in this parentheses the path name.
So when you have, for example, up here, right, I was trying to provide the path to the California Housing Test.csv. The
Mhm.
path is indicating all the directories to go into users, Kaylee Lau, downloads, Python, so on and so forth. And then the last one is the file itself.
Mhm.
So here I'm just, yeah, I could have done, like something like this, right? I could have said, if I ran this now, okay, and then let me share my whole screen. Now in my downloads folder, right, that text file is now saved, right? However, I didn't want to put it in my downloads folder, so I just had the text.txt and it would save that into my current directory. Did that make sense?
Yeah, yeah. Thank you. Thank you so much.
Okay, no problem. Okay. So, we're going to now talk briefly about, I'm not going to go over the append method today, but just know that when you go into read mode, the file has to exist for us to read it, right? If there is no file, it's going to produce an error. For the write mode, it's going to create a new file if one doesn't exist. But if one already exists, it's going to rewrite or overwrite on top of that. The append mode is different. It's going to add to an existing file, right? And if that file doesn't exist, it's just going to create it. So I want to talk very briefly about a handy built-in module for working with the CSV files. Um, we're not going to focus too much on this, but you can import CSV. So we've just imported this module so that we can use use it and say with open, okay? And I'm just going to copy this file path again to the California Housing CSV. Okay. And I'm going to put it into read mode. I'm going to assign the open file or the file object to F. And now I'm going to do contents dot, or sorry, is assigned CSV dot reader F. So this is creating a CSV reader object where and it's going ahead and we can now reference it through this variable. For a row in content, print row. Okay. So before we were just working with general like files, but this is specific module for CSV files. Again, this is not really the focus of today's uh, class for this topic, but just to highlight that you can actually use this CSV module, right? And it has this dot reader method, and then we can go ahead and iterate over this contents, right? So it's being assigned all of the contents, and we can go ahead and print it. I think the next thing though is pretty handy. So this is going to tie in some of the concepts that you've learned about when it in your shell and Git module. So we're going to import the OS module. And this is going to let us navigate the computer's file system. And we're going to be able to work with folders that are stored locally on our computer. Okay, so I import this module. And if I do os.get cwd, this stands for current working directory. Okay. I can see the path to the folder that I'm currently in, right? This is going to look very similar, again, to what you did with the shell content. So I can see now the folder that I'm currently located in. So this goes back up to, I had some questions about where text.txt or provinces.txt was being saved. It was being saved into my current working directory, which is this path. Okay. And OS is just a module that exists that we're loading in and then we're using. Okay. Can also do os.list.dir for list directory. This is going to show us all the contents of the current directory. Okay. This is the same as doing ls, right? When you are using bash, right? You just do ls and you can see all of the contents of the directory. This is the same thing. So OS path submodule also provides really useful ways to handle and manipulate paths. Let's go through an example and then I'll talk about that. So I'm going to do os.getCwd. So I'm getting the current working directory, the path of the current working directory, and I'm assigning it to this variable. Okay. Then I'm going to have an empty list. And then I'm going to have a for loop for I in os.list.dir. And this is going to, so here I get the current working directory, and then I also have an empty list. I'm going to iterate through, right, a list that contains all of the file names in my current directory. Right? So if this was os.lister, I'm going to iterate through each of the file names that are inside of my current directory. Okay. And I'm going to say full paths.append. Each time I go through one of those file names, I'm going to take os.path.join. This is a really great way to create correctly formatted paths from separate folder and file names. So it's going to join the current working directory with the file name, and it's going to do this in a way that is correctly formatted. Okay. So I create this joined path, and I'm going to append that to my empty list. Okay, I'm going to walk through this one by one again, but let's just run this and then let's talk about it. Okay, so os.getCwd, right? This is the output, where my cursor is circling. If I run this os.getWorking directory, I am located in this directory at the moment. Now, if I do os.lister, it's going to list all of the files that are located inside of the current folder. So I'm seeing all of the contents of my current folder. Um, so we're taking these and let's apply it to a little bit more of a complicated example. Yes, Omer.
Hey Kaylee, so I tried to do the os.getCWD,
Mm-hmm.
and for me, I've written in the chat, it's just one slash. That's it.
Oh, you're probably
I'm in a DSI participant thing in the VS Code. I'm using a Mac,
mhm.
and
Um
that's how it gives me.
I
So
would
what?
say then it could be that where you're located. If you're located, for example, let me share my screen. Um, Great. If you're located here, this is considered, I guess, your root directory. So it's going to be returning that. So you could be just in your root directory. If I go into users and then like so on and so forth, right? You go further into other directories, but for you, you might just be in your root. So that's fine.
Maybe, yeah. So I probably, so once the way I open the VS Code, I just go into the search thing on the top at the main once I open my laptop, I just find the VS Code and open it right there on my desktop. I don't go into the downloads or into any of like my folders with my name
Yeah.
or anything. That's
Hmm.
the reason that it's coming just in.
Yes.
Okay.
Yeah. Yeah, that's fine. You're just working out of your root directory. Yeah.
Okay. Got it.
Um, okay. So, now let's put this together, right? We've looked at the get current working directory method and then the list directory method. Let's combine this into a little bit more of a complicated example. So I'm getting my current working directory and assigning it to the CWD variable, and I've created this empty list. Okay. So os.listdir is providing me with a list with all of the files, all the content in my current directory, right? So for the first iteration of my loop, I is going to take on the first value of the output of os.listdir, which is this string here, right? And then we come into the body of our for loop, and this OS, and always work from the inside out, right? When you have like multiple functions and methods, right? You always go from the innermost one to the outermost one. So this os.path.join is just a very useful way to combine paths and file names together and to ensure that it is going to be properly formatted. So it's saying join your current working directory. Your current working directory with this file name and ensure that it is properly formatted by using this os.path.join. Okay. And so then once you have them together, oops, it's going to look like this. Okay. And then append that to the full paths empty list. So now full paths has this, right? It has this. So full paths, this first item has been added. Now let's go on to the second iteration of my loop. I is going to take on the second value in the output of os.listdir, right? So that is this, right? This was the output of os.listdir, and it was the live coding notebook for December 4th today. Okay. And then I'm going to join that with the current working directory. Okay, so that's going to look like this, right? I've joined that with the current working directory. Okay, and I'm going to append that to full paths. So now full paths has two items inside of it. It has the one for November 27th, and now it has it for December 4th. And we're going to keep doing this with all of the files in our directory. And so this is why full paths looks like this. Okay. Are there any questions about this example? Okay. I'm going to go through one more example, and then we're going to talk about object-oriented program very briefly. And then we'll take a break, and really I think the most important part of today's live learning session will be the NumPy introduction, which is what we're going to then delve into. So text is going to be lavender is a small purple flower. Okay. If os.path.exists plants.txt print plants.txt already exists. Else with open plants.txt w write text. All right. So I'm going to pull up my Explorer window on the left for the purposes of explaining this example. But we have this string, lavender is a small purple flower, and we're assigning it to the variable name text. We are going to check if the current file plants.txt exists in our directory, right? Plants.txt, right? This is my current directory. Let me just plants.txt doesn't exist in here. I have provinces and I have text, but I don't have plants. So the first time I run this if statement is going to execute to true, and I'm going to print plants.txt already. Sorry. I misspoke there. One moment. Okay, so the first time I run this code, plants.txt doesn't exist, right? I have provinces and text. So this is going to evaluate to false. Apologies. I hope that wasn't too confusing. But this is going to evaluate to false because I have provinces and I have text, but I don't have plants. So I'm going to now go to execute what's under the else statement. And it's going to say open plants.txt as a write. Write a file with this text. Lavender is a small purple flower. So the first time I run this, it's going to write this text file. Lavender is a small purple flower. Okay. Now, when I go ahead and run it again, this first if statement is going to evaluate to true because this plants text file now exists. So this time it's going to print plants.txt already exists. Okay. So this was just kind of incorporating, how we were opening and writing files along with the if and else statements that we'd previously learned about. All right. Okay, we're going to talk very briefly about object-oriented programming. And we're not going to cover getters and setters today, but it is a part of the slide document, so you can read that as kind of bonus material. But we're going to talk about what objects are in Python now. Yeah, there's a hand up.
Is there a way we can use just the extension .txt and look for just the text documents like txt as opposed to a specific file name?
Yeah, had you learned about wildcards, I think they're called in?
Yes.
Yes. So I believe they also work with Python. Let me just do a quick Google search to confirm that. But I think that you should be able to do the same thing. Um, yeah, Python supports wildcards, but you have to actually use the glob module for this. So I can send the documentation for that, and then you can explore that um, as well. Let's see. Oh, so I just sent the glob documentation. So that will allow you to kind of work with wildcards similar to with shell. I hope that answered your question.
Okay, thank you.
Yeah, no problem. Um, Sorry, I'm getting a message. Are folks so I don't know if this is answering the question correctly. So the live code is not uploaded yet for today because I'm still currently coding. Um, but I'm going to post it after the class onto the GitHub repository. So I don't know if that was the question, answered if that answered the question, but again, everything I'm doing today is going to be uploaded onto the GitHub repo right after class. Yesterday's should have been posted already. Yep, a hand up.
Hi. I just wanted to ask one question. Like, I tried to write list of list, so it gave me an error. So I just wanted to know what all kind of data types that we can use in the write function.
Oh, so you did a list within another list and then you got an error.
Yeah.
Um, Interesting. I've never actually tried that. Again, I'd refer to the documentation, to see what is valid. I'm just pulling it up now. Um, Waiting to file. Oh, sorry, I do understand. Yeah, I think it would just be for the right method. My understanding, where did I put this? Is that you can either do a string um or an iterable, but I guess what you're saying is you can't have an iterable nested within another iterable. So
Right.
I guess it would just be that first level. I hope that answered your question.
Okay, so it should be a first level iterable, otherwise it won't work.
Yeah, yeah.
Okay,
Mm,
thank you.
no problem. Okay, let's talk about object-oriented programming briefly. So we're going to talk about classes, objects, methods, and attributes. So that was just a lot of terminology. But a class, oh, this is marked down. A class can be thought of as a blueprint, okay? Blueprint or template for creating objects. I'll talk about what an object is in a moment. So it's a blueprint or a template. It defines the properties, which we call attributes, and behaviors, which we call methods, that objects of that class will have. So, um, and in a way, you can think about it as a class being some user-defined data type, right? We've introduced lots of different data types that are inherent to Python. We talked about integers, floats, strings, so on and so forth. But now think about a class as being a user-defined data type. Okay. And it's going to have properties. All of your data types are going to have properties, which we call attributes, and behaviors, which we call methods. Okay. Then we have objects. So this is a specific instance of a class. So and objects have state. Okay, so think about that as attributes, your attributes or your properties, and behaviors, which we called methods. Okay. And then we have methods. So kind of talked about it briefly before. You've also heard this word get thrown around for the last couple of days. But a method is a function that is associated with a class. Can be called on objects of that class to perform certain actions or operations. And then the last thing is attributes. Now, these are pieces of data that belong to an object, and they represent the state of the object. Okay, so I'll give the example of a basketball player. Okay, think about a basketball player, and let's talk about some of the attributes that they can have. A basketball player can have a certain position, a certain team that they play for, and a certain jersey number. These are all attributes, right? But they can also do certain things, right? A player can dribble, shoot, or pass the ball. So those are all things that they can do. So those are methods. And um, so then we can have specific instances of this basketball player class. So what I mean by that is I see Laura on my screen. So Laura can be a basketball player and can have a specific position, team, and jersey number, right? And so Laura has attributes, but then Laura can also, dribble, shoot, or pass the ball. So then Laura can do these things and can do these methods. And so Laura is an object. Laura is an instance of this basketball player class. I can also be an instance of this basketball player class, and I can have my own, position, a different position maybe, my own team, perhaps on a different team, and my own jersey number. So I can have different attributes, and I can also, dribble, shoot, or pass ball. So I can also have methods. So, we're both basketball players, right? So we're both a part of the basketball player class. But we are objects, different objects. Laura is one instance of the basketball player class, and I am a different instance. Okay? Because we are part of this basketball player class, we have inherent methods and attributes associated with it, right? So I'll go through another example with cars, and then we'll actually create our own car class. Just to summarize, a class, think about it as a blueprint for creating objects. Objects are specific instances of those classes. They have their own state and behavior, which we call attributes, as well as methods. Okay. All right. So let's talk about cars. So, kind of similar to that basketball analogy, we can have cars, And you could capture a single car by going car name is Taylor, car brand is a Honda, and then car model is a Civic. Oops. Sorry. Car model is going to be a Civic. And then you can have your number, and I'm gonna put something random here. So pretend that's a vehicle number there. So this is how I capture a single car, correct? But what happens if I wanted to capture multiple cars, more than one? And if you were then to take this, copy and paste it, say car name 2, car brand 2, car model 2, car VIN 2, and then to rename this into whatever you were going to say, the Toyota, right? Corolla. I don't know if that's how you spell it, but you get the idea. We're here, and this is really highly inefficient, right? So that's why object-oriented programming is very handy. Okay, we can take a generic entity like this car and then write out a blueprint for it and create as many cars as we want. So let's do that. So to define a class, we have the keyword class, and then we have the class name. Typically, the class names start with a uppercase letter, right? So I'll have class car, then have a colon, and then when you hit enter, you should be indented. I'm going to explain what this is, but you will always have the first thing be this def init, okay, with 2 underscores. These are 2 underscores on the left and 2 underscores on the right. Then we're going to have self is always going to be the first parameter, name, and then this is going to be specific to your class definition. So for a car, you could have a name, the brand, the model, and then the number, okay? A colon. And now I'm going to always do self dot name is assigned name, self dot brand is assigned brand, self model, right? Okay. I'm going to talk about and break this all down in just a moment. Okay, but if I now create an object, so I've defined this class, we're going to go into the details on what all of these mean, but just take in that we've defined this class, and I'm now going to create an object or an instance of this class, okay? So I can just write the class name, and then inside I can pass the specific attributes. So I'm going to say that example from before. I'm just going to copy and paste this from the slides. You can put whatever you want. I'll just keep it consistent with the slides, but you can type anything you want here. Okay, but the idea is it's going to take Taylor and assign that to the name, Honda for the brand, Civic for the model, and then this for the VIN, okay? So now I have this class definition. I've created this class definition. I've created an object, which is a specific instance of my class, right? With specific attributes. Just like how I was saying that Laura is one basketball player with, a jersey, a team name, and a position. And I'm another basketball player with another jersey, position and team name. And so you define what those are here. Okay, and then you assign that to your object. So now car is an instance of the class, and run this. And now I can access those attributes. So if I did model, you can see it's going to return Civic. Car dot name is Taylor. Car dot brand is going to be Honda, right? So there's attributes, but there are also methods. Okay, so I said attributes are pieces of data that belong to that object. Again, going back to that basketball example, just like how Laura can dribble, shoot, and pass, that's something that that object can do. Just like that, I can also dribble, shoot, and pass. That's something that I can do that my object can do. So we're going to define some methods here. Again, I will go over the specific syntax in a moment. I'm going to have cars can honk. Okay. So now I've defined my class. I've, gone ahead and kind of set all of those attributes. And now I'm defining a method. This method is called honk. And I can go ahead and go car.honk. Make sure that you rerun this again. So I just reran this with the method defined. And now my car can print beep beep when I call that method. Right. So my car is the object. So this class is this blueprint or this template. So this is my class. Then I've gone ahead and created an object, an instance of this class, and I've assigned it to the variable car. This object has attributes, right? It has a specific model, a name, etc. And it also has methods, things that it can do. In this case, it can honk. Okay. So this is the high level about how classes, objects, methods, and attributes work. I'm going to go into some of the syntax details. Everyone is probably wondering what the heck this init is and these selfs. So let's talk about that next. Okay, what's the best way to do this? I'm going to add to this little note here. Okay, so what is init? This is a special method in Python classes. Okay. So notice here on the left, I have 2 underscores, and then on the right, I have 2 more underscores. This is called a dunder. So this init is a special method in Python classes. So it stands for initialize. And every time you create a new object, right, a new instance of a class, it is automatically going to call this init method. It's going to run this and go ahead and initialize all of those attributes, right? So it's initializing the attributes. So when I create this object, this new instance of the class, I have all of these attributes that I want for that specific instance. And now automatically it's going to run this init method and go ahead and assign and initialize all of those properties and attributes. Yeah, there's a question on the practical use cases of object-oriented programming Python. We have been using methods and objects throughout this entire module so far. So if you remember, we've been working with string methods. We've talked about list methods and dictionary methods and so on. So we've been using them throughout. And the really key point about having classes is its encapsulation, right? So by creating a class, you create a data type that can only have certain attributes and can only do certain methods. So you are forcing that piece of data to be essentially limited in what its capabilities are. And that helps us encapsulate our code and make sure that we can manipulate it like that. So, for example, you don't want your text to behave as if it's another data type, right? So it helps us kind of force things into specific data types, if that made any sense. Okay. So let's continue with this explanation on, so we've gone over init, and let's talk about the self. So self is a reference to the current instance of the class. Whenever you have a method inside of a class, right? These are all methods. And this first one, like I said, is a special method that initializes all of those attributes, and it's always going to be called whenever you create a new object. But anytime you have a method inside of a class, the first parameter is going to be this self, okay? So this is referencing the current instance of the class. When you call a method on an object, right? So here, for example, when I wanted to do honk, Python is going to pass this car object as self. So now when I go with honk, I know that it's referring to this object, this specific instance of my class. Okay. Let's go through one more example with a person class, and then I'll reiterate those concepts again. Okay. And then after that, we'll take a break. Okay. So let's create a class called person. I'm going to say, so again, every time you have to have this init, which stands for initialize method first. And then inside every method, you have to have self as the first parameter. So this init is going to always automatically be called when you create a new object, and it's going to initialize all of those attributes and properties. This self is providing a reference to the current object, okay, to the object itself. So it's saying it's giving Python a reference to the current object. And so let's say self.name is going to be assigned name. Self.age is going to be assigned age. So what can a person do? They can greet. Again, every method has to have this self parameter. And then we're going to do print. Hello, my name is okay, self.name. Okay. And I'm going to run this to define the class. So I've created this class. This init is a special method, right? It's automatically going to be called every time I create a new object, and it's used to initialize all of those attributes. And then I have this self parameter. It is always going to be the first parameter in every single method, and it's a reference to the current instance of the class. Okay. It allows Python to understand what the current that object is. Okay, and to answer the question, you do have to use self. It's a keyword, yeah. Okay, and then we're gonna go ahead and let's use this class that we've defined. I'm gonna say person1 person is going to be Alice, and the age is 30. Okay, so I've created this object, this specific instance of the person class. When I create this object, automatically this init method is going to run, and it's going to initialize all the attributes. So it's going to take Alice and assign that to name, and then 30 and assign that to age. Now, person one has the attribute of name as Alice. Oh. And then person one is also going to have the attribute age as 30. Person one can also have the method greet. And greet is going to print, hello, my name is Alice. Okay. So again, init is used here to initialize the name and the age attribute of each person object. And then self.name and self.age refer to the name and age attributes specific for that object. And then we have this greet method, which is going to have self. It's a reference to that object. And this is going to allow the method here, print hello, my name is, and then you print the name. Okay. Again, your slides go into getters, setters. Again, we're not going to cover that today just in the interest of time so that we can go over the NumPy content. But you can feel free to take a look at that outside of the class. All right, we'll take a break now. Let's come back at 7:26, where we're then going to go into NumPy. So I'll see everyone back here in 10 minutes. Okay, we're gonna start back up now, talking about the NumPy library. So let's start with a discussion on what NumPy is. Um, NumPy is a Python package for scientific computing, and we work with arrays. Um, you can think about it as a grid of elements, and all of those elements are going to be the exact same data type. Just going to paste in a table. So this is just comparing NumPy arrays and Python lists. Yeah, a hand up.
Kaylee, can you please enlarge your screen? It's a little smaller. It's if there is a possibility.
Um,
Like,
sure. I think this is probably, I'm gonna
yeah,
keep
this
it as is, and then I think you can actually zoom in on Zoom yourself just because
oh,
if
it
I
was zooming in while you were doing it. I don't know, but like,
yes, this is okay, we can try this. Yeah, we can give this a shot. Yeah, so Um, I'll just if it starts all getting cut off with the longer commands, I might switch back, but I think you're right for now. This is probably better. Um, so this is just a table comparing NumPy arrays to Python lists. Again, the thing to remember is that with NumPy arrays, these are the fundamental data type for the NumPy package. Every element has to be the same data type. They are a fixed size. They're n-dimensional, which we're going to talk about what that means. And we choose to use NumPy arrays over Python lists because they're faster to process and they consume less memory. Okay, so to use the NumPy library, we're going to do import NumPy as MP. This as MP is an alias that is used, very commonly used, so that rather than having to type out NumPy every time we want to use it, we just type out NP and it's faster. So I've just imported the NumPy library and now we can use it. So the main object in NumPy is the array, okay? And we have dimensions in an array, which we call axes. Most of them are going to be one-dimensional, which we call vectors, and then two-dimensional, which we call matrices. Those terms may be familiar to you already. So we create an array by doing np.array, and then we can go ahead and pass data in as a single value, such as a list. So I could have 1, 2, 3, 3, 2, 1. If for some reason you couldn't run this first line, this was part of the instructions that were sent out about 2 weeks ago to make sure that you could import this. You can switch for today to using Google Colab, and then that should already have NumPy in there. So just type in Google Colab into your browser, and then you can sign into your Google account and use that. Okay, so I've created a array, and here I have my first axis, which is of a length 2, and my second axis, which has a length of 3. Let's talk about what that means. So I have these outermost brackets, which are indicated here in the pink color. These enclose the entire array. Okay. Inside, I have two inner brackets, right? Two sets of inner brackets. So two sets of inner brackets, those are indicated with the blue color. Okay. So that is indicating that the length of each one represents a row. Okay, each one here represents a row. And this is indicating that the length of the first axis, which is the number of rows, is 2. We have 2 rows. The length of the first axis, which is the number of rows, is 2. Within each of these rows, there are 3 elements, right? We have 1, 2, 3. They're all separated by commas, and so because of that, we say that the length of the second axis, or the columns, is 3. The length of the second axis, which is the columns, is 3. We have 3 columns. I'm just going to share my entire screen and explain briefly on the right. You should see, Omer, if your question was already answered, you can put your hand down. Yeah, great, thank you. Otherwise, feel free to keep it up if you still have one. So we have here just this graphic I created to illustrate a one-dimensional array, right? So we have one dimension, okay, or one axis. Then we have 2 dimensions, right, or 2 axes. We have, in this case, rows, 3 rows, as well as 3 columns. And then here, this last image is just showing a 3-dimensional array. Okay. In this case, we have rows, columns, and then we also have another dimension there. So you can see how it can get more and more complicated as we keep increasing the number of dimensions. But this is a concept that is fundamental to NumPy arrays, right? We have these different dimensions. Okay. All right. So this array is going to have attributes. We've just learned about this. So I can take a look at A, right? We've just created this array. This array has 2 rows, 3 columns. Okay, the rows are the first axes, so that's 2. And then the columns are the second axes, which is 3. Okay. And we can have a take a look at the dimensions. So this is a 2-dimensional array because we have 2 axes, right? Rows and columns. We can take a look at the shape. It's a 2 by 3. There are 2 rows and 3 columns. I'm just going to zoom out. If folks find this hard to see on their screen, you can maybe try zooming in with, I think you can just go like this with your pad or command or control plus. Okay, and then we're going to take a look at the size attribute. So this is telling us how many elements are inside of this array. So we have 6. Okay. And then I said that the important thing to remember about NumPy arrays is that they all have the same data type. So if I take a look at this D type attribute, you can see it saying that they're integers. Okay, so they're all integers, which is correct. Okay. We can also create arrays with placeholder content, right? Because up here I said that NumPy arrays have a fixed size. Right? So they have a fixed size. We have to define the size from the beginning. So sometimes we want to create a NumPy array with all zeros as placeholders. Okay, that's the placeholder content. This is really handy when you know how many elements are going to be in the array, but not necessarily the values. So it's NP zeros, and then you can have a tuple inside of it. Remember tuples from a couple of sessions ago, and that's going to have the size. So I want a 2 by 3 by 2 array of zeros. All right, let's take a look at the, and remember that you're passing in the size as a tuple. That's why you have the double parentheses. So let's take a look at the brackets here. The first set is indicating that this is my array. Then if we go one step further, right, we have another set of brackets, and we have 2 of those. So that's this 2-dimension. And then if we go another step in, right, we have 1, 2, 3. So this is this 3-dimension. And then inside of that bracket, we have 2 elements. So this is again the 2. You can think about that just as this image that I'm showing here on the right, right? You have rows, columns, and then that third dimension. We can also create an array of ones. So I had created this NumPy array A, and if I do NP ones like A, it's going to create an array of ones with the same size as A. I know I'm going to be going through a lot of different methods right now, and you are by no means expected to have them all memorized, right? At the moment, I still don't have all these memorized. The point is that you get a sense of what the functionalities of NumPy include, and then you can go ahead and search for things afterwards, you know, like take a look at the documentation and and then you can find the specific commands that you're looking for. But again, this is just to get a sense of what the capabilities are of this NumPy package. Okay, we can also create arrays by specifying the range that you want the values to go through. So if I did np.arange 1, 10, 2, this is going to indicate the start number. So I want to start at 1. I want to go up to but not including 10, and in steps of 2. So start, stop, step is the last one, step. Okay. Starting at 1, going up to but not including 10, and in increments of 2. Okay, let's do another one. np.arange 0, e 0, 1, 0.1. Starting at 0, going up to but not including 1 in increments of 0.1. Okay. Notice here, everything in this array is a float, right? There can only be one data type in arrays. Okay. Sometimes we want to generate random numbers, and we can actually use this np.random.randint, okay? And it's again going to have a start. So I'm going to start at 1, stop. I want the numbers to go from 1 up to not but including 10. And then you're going to have a tuple indicating the size. And I want it to be a 3 by 4 matrix. So I've created this 3 by 4. I have 3 rows, 4 columns. And in it, the values are randomly generated, but they range from 1 up to but not including 10. So every time I run this, notice how the numbers are changing, but the numbers are always in the range of 1 up to but not including 10. Okay. This is really great because sometimes we need to have randomly generated numbers, but it makes it hard because it doesn't allow us to reproduce the code each time we run it, right? Every time I'm running my code, it's generating a completely new set of random numbers. So let's say we want to get the same, we still want random numbers, but we want the same sequence every time I run the code. I want this exact same sequence every single time I run the code. Each number is still random. Each number was randomly generated, but I want it to be reproducible. If that's the case, you can do something called setting the seed. Oops. Okay, let's talk about what this line does. So notice now I've run it. It's created this set of randomly generated numbers that range from 1 up to but not including 10. But each time I run this cell now, the exact same set of random numbers are being generated. So I've just allowed myself to create a reproducible set of random numbers. A lot of confusion usually happens around what this seed is. So think about it as it is an initial value that is provided to a random number generator. So it's an initial value that's given to that random number generator, and that random number generator then starts the sequence of creating your random numbers. So by setting the seed, you're ensuring that that starting point is always the same. And because of that, you're going to get the same sequence of random numbers every time you run your program. When you don't have this seed, Python is going to use something like your current system time or some other source of entropy in order to initialize that generator. And then that's why you get all of the numbers changing every time you run it. So whenever we set the seed, we're allowing ourselves to get reproducible random numbers. Now, if you change the seed, so let's say I change it from 1 to any number. I'm just going to do 2810941. I just randomly type that in. Okay. The numbers have now changed, but every time I run it, it's going to be the same. This number now is essentially providing an initial value for my random number generator to then start the sequence of generating those values. So I'm setting that initial starting point to then create those random values. So this is allowing me to have reproducible results. So you can set your seed to anything you want. You can have it as 50, right? Or whatever number you want. The idea is that now every time I run the code over and over again, I get the same set of random numbers. So I hope that made sense. Okay. Yeah. Jason, your hand's up.
Yeah, so do we have to reference a seed every time to bring back the numbers?
No, oh wait, actually, I don't know if I completely understand your question. Can
Yeah,
you?
so you said that if you put a seed, like in this case you put 50, and it's
Mhm.
going to produce the same numbers in the array, does it mean that you have to reference the seed as 50 every time you call the random?
Oh, I see. Yeah, no, you don't have to. It's going to keep that for the entire random submodule essentially. So you're setting the seed for anything that works with this random submodule is now the seed has been set. Yeah, you don't have to reference it.
Okay, thanks.
Yeah, no problem. Okay. We can also repeat values. So if I do np.repeat 10.5, it's going to create a array where 10 is repeated 5 times, right? 10 is showing up 5 times. Let's say I had this one-dimensional array, and it's going to be np.array 1, 2, 3, 4, and 5. And then multi-dimensional array is going to be np.repeat one-dimensional array 5 times. Okay, so I have this one-dimensional array. It has values 1, 2, 3, 4, 5. And now I'm applying this repeat method to it with 5 times. Oops. Notice how it's repeating each element in the array 5 times. One is going to be repeated 5 times. Next element's going to be repeated 5 times. But if we use the tile method, so if I actually go multi-dimensional array, it's np.tile, okay, this time it's taking my one-dimensional array, 1, 2, 3, 4, 5, and it's repeating it, but in a way that creates a multi-dimensional array. So I'm saying, I want you to repeat it 5 times down the first axis, and only once in the second. So it's going 5 times down the number of rows. And that's why we have it creating this multi-dimensional array. So it's a key difference between the repeat method. Here it repeats each element that number of times, versus tile is going to take your array and take that entire array and replicate it, right? We can also create another multidimensional array. Oops. What am I doing? Oh, I can't spell. Okay, there we are. Whew. And this time I'm saying take that entire array, that one-dimensional array, which is 1, 2, 3, 4, 5. Now repeat it 3 times in the first axis, which is repeat it 3 different rows, and also 3 times in the second axis. Make it also 3 different columns. So I've now tiled it so that I have it repeating into this multidimensional array. Okay. Let's talk about reshaping arrays. So if I have B, which is an array, I'm going to have 5, 4, 3, 2, 1, 0, and then 10, 8, 6, 4, 2, 0. Okay. So I have this array B, and if I want to find the transpose of it, I can find the attribute, right? This is how we get an attribute. We have period in the attribute name. And the transpose is when all of the rows become columns and all of the columns become rows, right? So all of these rows, this row 5, 4, 3, 2, 1, 0 is now becoming this first column where my cursor is circling 5, 4, 3, 2, 1, 0. This second row 10, 8, 6, 4, 2, 0 is a row and it now becomes a column. So now we have 10, 8, 6, 4, 2, 0. It's now a column. Okay. I think to answer the question in the chat, if that was a reference, oh, so the reason why it wasn't 1, 1, 1, 2, 2, 2 was because we used tile, not repeat. Repeat is going to repeat each individual element that number of times. Tile is going to repeat the entire array that many times. So I hope that made some sense. Yeah. Okay, so we showed how we could find the transpose of an array. We can also reshape the array. So I can make B a 4 by 3. So here, let me just put B first. Okay, so here this is B, and if I reshape it to now be a 4 by 3, you can see that it has 4 rows and 3 columns. It's being reshaped to a 4 by 3. We can also flatten it. So now I've taken this array and I flattened it into 1 dimension, right? I flattened it into 1 dimension. We can also stack arrays. So just as a reminder, this was A and now I have B. Okay. So this is A and B. I can stack them horizontally. Where I take B, so I take B and I stack it with A horizontally. So you can see B is 5, 4, 3, 2, 1, 0 and 10, 8, 6, 4, 2, 0. Okay, so this was B and I'm stacking A horizontally next to it. So A is 1, 2, 3, 3, 2, 1. So they're being stacked next to each other horizontally. I can also stack them vertically. But if I try to just do B, A, I'm going to get an error. Because if I tried to stack B and A horizontally, it's not going to be there's going to be a mismatch of sizes, right? You can even just imagine putting these two as they are on top of each other. There's a mismatch of the sizes. So we have to reshape B to be a compatible size. And let's go with a 4x3. So I've taken B, okay? I reshaped it to be a 4x3. Okay. So this is A and this is B reshaped. Actually, let's put this one. And now think about them just being vertically stacked, right? You can see that this was B and then this is A, and they're now just vertically stacked. Okay. We can also perform some operations on these arrays. And this makes it useful instead of having to do loops. So if I do mp.array 5, 10, 15, 20. Okay. So that was array 1. Now we have array 2. It's going to be mp.arange 5, 9. Okay. This is array 2. Okay, so now I have these two arrays. I've created array 1, which has the values 5, 10, 15, and 20. And then, right, so this is exactly what I get, array with a 5, 10, 15, and 20 value. And then I can create a second array, okay, where I have it ranging from 5 up to, but not including 9. So it goes 5, 6, 7, and 8. So I've just created 2 arrays. Now I can perform operations on them when they are the same length in a certain axis. So for example, you can do array 1 minus array 2. Okay. And now it's taken each element of the arrays and subtracted them. So for array 1, it was 5 minus array 2, which was 5, I got 0. 10 minus 6 gave me 4. 15 minus 7 gave me 8. 20 minus 8 gave me 12. So I just subtracted each of those elements. You can also multiply each element. So if I took array 1 and multiplied it by 2, okay. So as a reminder, this is array 1, 5, 10, 15, 20. I can multiply it by 2, and each element is going to be multiplied by 2. So 5 is going to become 10, 10 is going to become 20, 15 is going to become 30, and 20 is going to become 40. Okay. So again, we can subtract 2 arrays from each other. It's going to subtract each element. And we can also multiply an array where it's going to multiply each element. Okay. Notice here, though, that array 1 and array 2 were the exact same size. Okay. What happens if I try to do subtraction, for example, with arrays that are not the same size? So if I had array 3 and it was a NumPy array with the size, with the values 1 and 2. Okay. So I've created this third array. So I have, let's try to add it to array 1. So I have array 1, and now I have array 3. Okay, these are my 2 arrays. Array 1 has 4 values and array 3 has 2. And if I try to add array 1 to array 3, yes, I see in the chat, I get a value error. That's correct. Okay, so again, we can subtract arrays from each other. And if the sizes, and we can also add arrays to each other, but the sizes have to be compatible. We can multiply arrays by a value, and it's going to multiply each element by that value. Okay. We can also apply methods to summarize the values. So if I had array 1 again, right? As a reminder, this is an array 1. I can go ahead and apply the dot sum method, which is going to sum all of these values. So 5 plus 10 plus 15 plus 20, and it's going to give me that value, which is 50. I can also take the max. So in this case, the largest element here is 20, and that's what I get as the output. And I can take the mean. In this case, it's 12.5. Okay. So we can check that. We can say 5 plus 10 plus 15 plus 20 divided by 5, and I get, divided by 4, and I get 12.5. So we've gone ahead and now we've applied these methods to find some summary statistics. So we've gone ahead and seen the sum of each of the elements of the array, the largest element of the array, and the mean of all the elements in the array. Okay. These are all methods, right? Notice how they're all methods, because the syntax is that we have the object, in this case, it's this array 1, a period, and then the method name. Some stats are available via methods, like we can see here, but some are only available via functions. So if you remember how we call a function, it's that you have the function name. So this np dot is just saying, hey, in the NumPy package, there's this function medium. So it's allowing us to reference a function inside of that NumPy package. And we can find the median of array 1. This is a function, okay? And notice how if I tried to apply this as if it was a method, I get an error. So how do you know which ones are functions and which ones are methods? You can take a look at the documentation, and you can also just try it out sometimes. But overall, like looking at the documentation will provide a lot of insight into which ones are methods and which ones are functions. Okay. We're going to talk about operations in multiple directions. So, we said that you can have multi-dimensional arrays like a matrix where you have rows and columns, right? And we can perform operations on these multi-dimensional arrays, but they are going to be broadcasted to repeat along one of the dimensions. So I'll show an example of what I mean by that. I'm going to create an array called tens. It's going to have 0, 120 in increments of 10. So tens is an array starting at 0, going up to, but not including 120 in increments of 10. Okay. Now let's chain another method. So chaining where we have we have a function here, and I'm going to chain a method to it. I'm going to say reshape it to be a 3 by 4. Okay, now when I run this again, notice how the exact same array is now a 3 by 4. There are 3 rows and 4 columns. We're going to create a second one called horizontal. Okay. And this is horizontal. And when I add tens to horizontal, let's see what happens. Okay. Notice how it's broadcasted. So in this case, horizontal is going to be added to tens, and it's going to be repeated along for each row. So for example, okay, for the first row of tens, it's going to be 0 plus 5, we get negative 5. 10 plus negative 10, we get 0. 20, negative 15, we get 5. 30, negative 20, we get 10. Now, horizontal is broadcasted. So again, this entire array is now added to the second row. So 40, negative 5, 35. 50, negative 10, 40. 60, negative 15, 45. And 70, negative 20, 50. Same thing again. This entire array horizontal is going to be added to the last row of tens. And that's why we get this output. Okay. We can also, let's see what happens when we create one called vertical. Okay. Okay, so in this case, I have the exact same, let me actually put it back up here so we can look at that. So I have the tens array again. This is a tens array. And then I have this vertical array. Okay, this is what vertical looks like. I can go ahead and now I want to add tens and vertical. So the first, all of vertical, it's a column vector. This column vector is going to be added to the first column of tens. So 0, 100, we get 100. 40, 200, we get 240. 80, 300, we get 380. And then again, for the next column, all of vertical, that entire column vector, is added to the second column. 110, 110. 50, 200, 250. 90, 300, 390. And so on for the remaining two columns. Okay, so we say that it's broadcasted, which means that this vector, this vertical vector in this case, is going to be broadcasted to repeat along the other dimension. Okay. So it's important to keep in mind when you're doing operations in multiple dimensions. I'm going to paste in something that I've added recently to the slides. So you can take a look at this and read it over and over again in the slides or in this live coding notebook. But so before I had calculated, I showed how we can, add arrays in one dimension, right? We were adding arrays in one dimension, and then we applied these methods also to the summary statistic methods to those arrays in one dimension. And then we built upon all that and we expanded it to multidimensional arrays. And we saw how when we are now adding or subtracting multidimensional arrays, One of them is usually broadcasted to repeat along the other dimension. This was one difference. And now let's see what happens when we apply those methods again to now these multidimensional arrays. So everything we worked with was to start off with one dimension, then we expanded it now to multidimensional arrays. The key difference is that we have to specify an axis. Okay. So if you want to find the values for the columns, we use axis is 0. And if you want to calculate it for each row, we use axis is equal to 1. So let's see an example. So this was tens, right? Now let's say I want to apply the dot mean method. Because this is a multi-dimensional array, right? When it was one dimensional, we didn't have to, we just did dot mean and that was it. But because this is multi-dimensional, we now need to specify an axis. So if I set axis is 0, what's going to happen, so to summarize, is axis is 0, it's going to do column-wise operations. So it's going to find the mean down the rows for each column. So it's going to do 0 plus 40, 0 plus 40 plus 80 divided by 3, okay? And I get 40.0. Then it's going to find the mean for, again, the axis is set to 0, so it's down each column or down the rows. So it's going to do the same for this next one. I'm going to do 10 plus 50 plus 90 divided by 3. And I get 50. And for the third, it's going to do 20 plus 60 plus 100 divided by 3. I get 60. Okay, that's 60 here. And then for the last one, just for completeness, we'll do that as well. 30 plus 70 plus 110 divided by 3. And I get 70. And that's this last item. So when we had one-dimensional arrays, we did not have to have this axis specified. There was only one axis to perform the operation on, right? But now that we have more than one dimension, we have to specify the axis. So if axis is set to 0, it's doing column-wise operations. It's going down the rows, okay? So that's what we saw here. If I now set the axis to 1, it's going to go to do row-wise operations. So it's going to go across the columns. So this was tens, and now I'm calculating the mean across the columns or row-wise, okay, row-wise. So we can think about it as the first one is going to be 0 plus 10 plus 20 plus 30 divided by 4, and I get 15. Okay. Then it's going to do the next row, which is 40 plus 50 plus 60 plus 70 divided by 4. I get 55. Okay. Then it's going to do the last row, which is going to be 80 plus 90 plus 100 plus 110 divided by 4. And I get 95. Okay. So to reiterate, what have we just done? We have talked about with one-dimensional arrays, how we can apply operations to them, right? We saw we could add arrays together. Where is it? Sorry. We saw that we could add one-dimensional arrays. So this was array 1 was one-dimensional array 2 was also a one-dimensional array. We saw we could add, we could subtract them, but the sizes had to be the same. We then saw that with one-dimensional arrays, we could apply different methods to get some summary statistics. And it would provide us with the sum, the max, the mean, etc. Okay, we then shifted gears and talked about multi-dimensional arrays. And we went ahead and said that if you have a multi-dimensional array, where is it? And you add it, right? Usually one of those so in this case, right, we had a column vector or a row vector being added to a 3x4 matrix. Then the row vector was going to be broadcasted to repeat along the all of the rows, and that's what we saw here. Same with when we had a column vector in a 3x4 matrix. The column vector would then be broadcasted to repeat across all of the columns. Okay. Then we also saw that when we applied summary statistics, we had to specify the axis. Okay. When the axis was set to 0, it would calculate the summary statistic for each column. Think about it as going for each column, it's going to find a value. Then when we had the axis set to 1, it would calculate it for each row, right? It's going to calculate the mean for each row, and we're going to get 3 values. So this was a lot of information coming at you all. But if you get the gist of it, which is that you have one-dimensional arrays that behave in one way, and then we expanded that to multi-dimensional arrays, that is the most important part. Okay, we're going to talk about, I think we'll get to indexing, slicing, and then we'll talk briefly about mutations. And then there will be a bit of extra content, just a little tidbit on logic and filtering in the slides that you can also go through on your own time. Okay, so we're going to go talk about indexing, slicing, and iterating. This is going to look very familiar. So we have array 1. Just like with strings and just like with lists, you can index them, right? So now if I say return back the value of array 1 at index 1, it's going to give me 10 because this is index 0. Everything is always 0 indexed in Python, and then this is index 1. So I get back 10. If I did array 1, 1 up to but not including 3, I'm going to say this is index 0, this is index 1, and I want to go up to but not including 3. So I get back 10 and 15. We can also iterate over arrays. So I just created a for loop here, okay? And it's going to, for each iteration, I is going to take on the subsequent value of that array. So for the first iteration, I is going to be 5, so I print 5. For the second iteration of my loop, I is going to be 10, so I now print 10. Third iteration, I is 15, I print 15. And the fourth iteration is 20, so I'm going to print 20. Okay. How about with multi-dimensional arrays? So is that tens array. If I want to index it now, I have to indicate the rows and the column. So if I wanted at row 1, column 2, I'm saying row 1, so this is row 0, row 1, and column 2, that would be 0, 1, 2. So it should return back 60. If I just had tens at 0, this is going to return just row 0, which is 0, 10, 20, 30. And I can also just get a column. If I do tens, I want all the rows at column 0, right? I want all of the rows. That's what the colon with nothing on either side of it means. All of the rows, and I want it at index 0. I'm going to get 0, 40, and 80. Okay. We can even slice it. So this one's a little bit complex, but I'm going to do, so this is tens again. And I'm going to do tens, 0 to 2, 1 to 3. Okay, so let's break this down. I want tens from row 0 up to, but not including row 2. So this is row 0 up to, but not including row 2. Then I want it from columns 1 up to, but not including row 3. So that's why I get 10, 20, 50, 60. Okay, I've just sliced it. This is the row. It always goes row, and then this is indicating the columns. Okay. Now, we talked about mutability a couple of sessions ago. NumPy arrays are mutable. So that means that if I change a NumPy array, any other variable that references it is also going to update. Okay, so this is going to be the last example, and then I'm going to spend the remaining 10 minutes to go through the assignment. If I have a NumPy array, so I'm going to create a random one with values that range from 1 up to, but not including 12, and I want there to be 12 values. So if I ran this, okay, it's just creating a random array with values that range from 1 up to, but not including 11, so 1 to 10, and there are 12 values. Okay. I want to then reshape this to be a 3 by 4. Okay. I just reshaped it to be a 3 by 4. 3 rows, 4 columns. So this was matrix, let's call it actually matrix 1. Okay, this was matrix 1. Matrix 2 is going to be assigned matrix 1. Okay. Now matrix 3 is going to be an independent copy of matrix 1. Okay, so matrix 2 is just is now referencing matrix 1. Matrix 3 is an independent copy. Okay. So when I change, let's say matrix 1, and I want to update the first row to be all zeros, okay, so I want the first row to be all zeros. You can see that matrix 1 has updated. Or sorry, not first row. Row 1, right? Because the first row would be this row here, which is 0. So I've updated it so that row 1 is all zeros. And matrix 1 is updated. Matrix 2 pointed to the exact same value, right? It referenced the same value. So it has also updated to have a row of all zeros. Matrix 3, however, oh, sorry, I called it just matrix. This should have been matrix 3. Matrix 3, I'm gonna run this all again. Sorry, folks. This is the thing with mutability. It makes it tricky when you have a notebook and you're running things out of order. Okay. All right. I just reran everything in the correct order with the right naming. Now, matrix 3, if you'll notice, hasn't changed. It still holds that original value because we made an independent copy of it. Okay, so this is just highlighting that NumPy arrays are mutable. Okay, I think we're gonna end off here. Like I said, there's a few examples, a pretty short bit in the slides on logic and filtering. So you can go over that in your own time. But I think for now it might be useful to just walk through the assignment if that's okay with everyone. So to answer the question in the chat, integers are not mutable, right? Integers, the data type is immutable, and that's why you're getting that output for that example. So it depends on the data type because strings are immutable, integers are immutable, floats are immutable. So some data types behave differently. Okay, let's go through assignments. All right. And actually, I'll keep, okay. So for this assignment, we are going to be working with, one moment. We're going to be assessing the efficacy of a hypothetical arthritis drug. So you are going to work with some data. So if you go onto the GitHub repository, under src/data, okay, src/data, there's going to be a subfolder called assignment 2 data. Okay. I've just downloaded the repository, so I'm showing you this on my local computer, but this is all on the GitHub repository. So you can go there and under src data, assignment 2 data, you're going to see a lot of files. Okay. So we're going to be using these for assignment 2. So the idea is that you have ran a clinical trial with 60 patients, and each of these patients were administered a drug for arthritis. And all of this data has been recorded in these CSV files. Okay, so I'm going to open up one CSV file here. I'm actually going to make my screen a little larger. Okay. All right. So each CSV file corresponds to a check-in session with all of the patients. So you're running the study and you meet with all 60 patients 12 different times, okay? Each row is going to represent a patient. So for example, row 1 could represent me. Row 2 could represent Daniel. Row 3 could represent Richard, right? So each row is corresponding to a specific patient. Each column, and there are going to be 40 columns, so 40 columns in each CSV file. Each column is going to correspond to a day, and it's going to say how many flare-ups, how many inflammation flare-ups that patient experienced on that day. So if I'm patient 1, right, I'm a row. Then on day 1, I had 0 flare-ups. Day 2, I had 0 flare-ups, but day 3, I had 1 flare-up. Then day 4, I had 3 flare-ups, right? So this is how all of the data is structured. Okay. So for this assignment, you are going to analyze the data to see whether or not this drug is effective or not. Okay. So for part 1 of the assignment, okay, you are being asked to go ahead with writing a program that is going to display the contents of the first file in this list, okay? So you're going to then take this all paths. So this is just a path. This is a list with all the paths to the CSV files, okay? And you're being asked to go ahead and just open the first one. So that's what this is doing. It's taking in that first file path, right? All paths at 0. So all paths here at 0. And you're going to read it. So it's in read mode. It's being assigned, that file object is being assigned to the variable f. And then you're going to just have to write some code here. So 2 pieces of code. The first is that you're being asked to use the readline or readlines methods to read the CSV file, which we're now calling f, in into a variable called contents. Okay, so apply read line or read lines to F, and then assign that to a variable called contents. Afterwards, we want you to iterate through contents using a for loop and to print each row for inspection. Okay, so iterate through contents using a for loop and print each row for inspection. This is going to look pretty similar to an example we did today. Trying to think. Yeah, something along the lines, somewhat similar. It's going to be different, but you can refer to some of these examples for guidance, okay? But it's going to be a little different, okay? But that's the point. For part 2, so for part 1, we just read one of the files, one of those CSV files, and then we went ahead and iterated through its contents. For part 2 now, we are going to create a function called patient summary. Okay. It is going to take in 2 arguments. The first is going to be a file path to the CSV, and then the second is an operation, a string. It's going to be a string representing a specific operation. So it could be the string mean, the string max, or the string min. Okay. If we go back to this CSV, I said, for example, what if I'm patient 1, right? I've recorded here 40 different columns, 40 different points, where I've recorded all of my inflammation flare-ups. I want to then, depending on what the operation is, if it's mean, max, or min, find the mean across all of these 40 values that I've recorded. Or I want to find the minimum across all 40 of these values that I've recorded. Or what's the last one? I want to find the minimum across all 40 of these values. Okay, so max, min, or mean for each patient. Okay. So the idea is that your function is going to read the data from a specific file path. Then it's going to say, oh, the operation is mean, max, or min. Okay. And then I'm going to calculate that for each row, right? For each row, I want to find the mean, max, or min, depending on what that value is. And then I want to go ahead and return that value. Right? We're going across the rows, right? So because of that, the axis is set to 1. That's why that axis is set to 1. Okay. And then now you just have to insert your code here in these 3 locations where you apply that operation. Okay, so we just talked about how to apply an operation or a method. Right? So you could do, where is it? Right, it looks something like this, along the lines of this, where we're applying the mean operation. Okay. Okay, and then finally, part 3. So for part 3, you're going to write a new function called detect problems. And the idea is that if I calculate the mean, so if I'm patient 1 and I calculate the mean for all 40 of my values, and for some reason it's 0, there could be something wrong with that data recording. Okay? Because these patients have arthritis, so it's highly unlikely that they've had no inflammation flare-ups across 40 days. So something's wrong. So we want to detect a problem. So you're going to take in a file path to a certain CSV, right? Any of these CSVs. And the idea is that it's going to read that CSV, and it's going to use the function that you define in part 2 to calculate the mean, right? The mean across all 40 of those recordings for each patient. So I go ahead and I find the mean for each of my patients. So I have here now 60 values because there's 60 patients, and it's all the means across those 40 values. And now I want to use this helper function that we've provided you with. Okay, so we've created this function. You can read through how it works if you'd like. The idea is it's going to check for zeros. Okay. And if it finds a zero, we want your function in part 3 to return true, saying, hey, one of your patients had a mean inflammation score of 0 and something fishy is going on. We've detected a problem. If it returns false, then that means that none of the patients had a mean inflammation of 0 and you're good to go. Okay. So, you can leave this. This is just for you to run so you can use this helper function. And your code here, okay, it's just going to be a single line where you can use this patient summary function from above to get the means, right? So you're getting the means. And then you can go ahead and then you're gonna have another line here, or you can have as many lines as you need. Sorry, not to dictate that, but you're going to start by using the function from part 2 to get the means, and then you're going to use this helper function we've provided you with to check for zeros in those means. And then you're going to return true if it finds a 0 and false otherwise. Okay. I know that was a lot of information. Are there any questions off the bat about this assignment? It is a little bit more involved than the first one. Yeah, a hand up. Igor, is it?
Yes. Hello. Sorry, I have one question because I'm a little bit confused that we have some in the first part of assignment. As I read our task, it's like write the program to read the files. As I found, we have to read all the files, but display just first one. Is it correct?
No, you do not have to. So you just have to read one of the files and display it. You don't
Oh,
have to write a program to do it for everything. Just take one and then display it.
yeah, okay. Thank you. That's clear.
No problem. I'll answer some of the questions in the chat and then come back to the hand. So, do we have to calculate the summary statistics for only one CSV file? So here when you're calculating the summary statistics, right? It's a function and it takes in the file path and then the operation as its arguments. So, because of that, you should technically be able to apply this to any of the CSV files. And you can apply it to any of those CSV files. Yeah, but it should only work with one at a time. I don't know if that answered that question. Send another message if that didn't make sense. Yeah. The helper function. Yep. I'm not going to go over that right now, but if you would like to, we have included an explanation on exactly how the helper function works. I won't go over the details, but the idea is that the helper function is going to find if any of those values output to 0. Any of those means have a 0 value. Okay. And if you have questions about how the helper function works, can feel free to reach out to myself for any of the learning support. Okay, let's go back to the hands. Sanjana, I think your hand's up.
Yes, hi. So I just wanted to ask one question about just a minute. Are you getting some noise in the background?
Nope, it's okay on my end.
Okay, yeah, that's great. So I was asking, so we have created one branch for the assignment 1 for the Python assignment, and in the same repository there is an assignment 2. So are we supposed to create another branch for it and create a PR for that?
Yeah, that's right.
Okay, okay. Thank you so much.
No problem. Farshid?
Yeah, hi Kelly. A quick question. I can see that at least in the file that you demoed, all the numbers were positive integers, right?
Yeah.
So how can we get a mean of 0?
I see what you're saying. Yeah, it could be, I think one of these might. The idea is just that if there was something wrong with one of these files, it could have zeros all across, right? So
Okay,
that's why
got
we're
it.
writing these. But yeah, I can't remember off the top of my head if one of them has all zeros. You could go ahead and change it manually and then test it out to see if it provides you with a false value too. Yeah. Sorry, I don't know if that answered your question or not.
Yeah, it did. Thank you.
Yeah, no problem. Okay, question in the chat. So for the whole assignment, we should just open one file. Just doing the first part helps us to do every task with data. Yes, exactly. So yeah, part 1 is for one file, part 2 and 3 are functions, and it should work on any file. Exactly. Okay. Are there any other questions? Okay. So this wraps up all of the content for the Python module. Like I said before, tomorrow we're going to have Tristan from Munich Re come in and give a case study presentation. We will still have office hours today after class with our learning support. And then tomorrow before class, I'll be present. And then again, the learning support will be there after class. And then on